Hello everyone, this is Hashita and Janvi Kumari. Our project title is Parking Slot Allocation using Reinforcement Learning. Manual parking slot allocation leads to increased waiting time, traffic congestion, and inefficient parking space utilization. To solve this problem, we developed an intelligent parking allocation system using reinforcement learning. Due to the rapid increase in vehicles, parking management has become difficult in public and private parking areas. Traditional parking systems often cause congestion and inefficient slot usage. Reinforcement learning helps the system learn optimal parking decision automatically. This project can be used in shopping malls, office buildings, smart cities, airports, railway station, and residential parking system. The objectives of these projects are to reduce vehicle waiting time, to reduce parking congestion, to improve parking slot utilization, to intelligently allocate parking slots using reinforcement learning. In this project, parking slots are fixed and predefined. One vehicle occupies one slot at a time. Vehicle arrives sequentially and RL agent observes parking slot occupancy status for decision making. The reinforcement learning agent acts as an intelligent decision maker. The agent observes parking slot availability, selects the best parking slot, receives rewards based on decision, and continuously improves its parking allocation strategy. The main AI concepts used in project is reinforcement learning using the Q-learning algorithm. The agent interacts with the parking environment, learns through rewards and penalties, and updates the Q table for future decision. The inputs to the system are parking slot availability, vehicle arrival information, and slot distances. The outputs are optimal parking slot allocation, reduced waiting time, and improved parking efficiency. We used race representation and Q-learning based reinforcement learning. Here, this is the flow of system architecture. The project requires only laptop or PC, no additional hardware is required. The system architecture includes vehicle arrival, parking environment observation, RL agent decision making, slot allocation, reward feedback, and continuous learning. Now I will demonstrate the working of the project. Here we initialize the parking environment. 5 parking slots are created, 0 represent free slots and 1 represent occupied slots. We also define the distance of each slot from the parking entry point. This function displays the current parking slot status as free or occupied. This is the queue table used in reinforcement learning. The agent stores the learned reward values in this table and uses them for future parking decision. This function represents the reinforcement learning agent. The agent checks available parking slots and selects the best slots using learned queue values. Here, the agent is trained using the Q-learning algorithm. The queue table is updated continuously based on rewards and parking conditions. This section visually displays parking slot allocation during the simultation. Green slots represent free parking spaces and red slots represent occupied parking spaces. This graph compares traditional parking allocation with RL-based allocation. This graph shows the learning performance of RL agent over multiple training episodes. Results are the reinforcement learning agent successfully allocated parking slots efficiently and demonstrated intelligent decision making using Q-learning. Through this project, we learned the basics of reinforcement learning, Q-learning, reward-based learning, visual simulation, and implementation of AI concepts using Python. We conclude that reinforcement learning based parking slot allocation system successfully improves parking efficiency, reduces waiting time, and optimizes parking space utilization through intelligent decision making. Future improvements can include real-time sensors, smart city integration, and mobile application support. Thank you.